Hello all. As a continuation of my lecture series in control systems, we have already discussed about the basic elements of control system, open loop and closed loop, along with the advantages and disadvantages, and also we learnt about mechanical translational system. So now we are going to discuss about mechanical rotational system. So whenever there is a rotation, we know that there will be an angle which is mentioned as theta and there should be some torque. So let us recall about what is the difference between translational and rotational system. So whereas translational system is to and fro motion, which is linear motion, whereas rotational is, here we have shown a picture, what is the axis of rotation and what is the torque and angle that we know. So let us list some real-time examples of rotational system. For example, as an electrical engineer, motor is one of the best rotational system example. So in this video, we are going to discuss about, we are going to have just an introduction and basic elements and mathematical modeling and its applications. So introduction is, there will be a torque and here we are going to consider moment of inertia which is mentioned as J, and there will be a torque, and due to that torque there will be an angle which is theta. And here we also going to know about, we are going to have a spring which is mentioned as K. So here, so let us have a gear train which is connected with motor torque and the load torque, so which is Tm and Tl. So its friction is mentioned as B1 and B2, and here we have a DC motor and a load, and DC motor have an inertia of J1 whereas load have an inertia of J2. So this is one of the real-time example of rotational system. So there will be a moment of inertia J1 and J2 and friction B1 and B2, and there will be a torque which is motor torque is Tm and load torque is TL with an angle of theta 1 and theta 2. So mechanical rotational system involves rotational motion about an axis. Either it may be on x-axis or y-axis. Commonly used in motors, generators, turbines, gear systems and flywheels. So these are mainly used components which acts in the rotational motion. So this is governed by Newton's law of rotational motion. So here we have some ideal elements. So angular displacement is mentioned as theta and its unit is radians, whereas angular velocity, which is d theta by dt, whereas radians per second, and angular acceleration, which is d square theta by dt square, radians per second square. So we already know that displacement, velocity is change in displacement with respect to time, whereas acceleration is change in velocity with respect to time. So that's why it is mentioned as when we d square theta by dt square. And applied torque is mentioned as T. Its unit is Newton's meter, and moment of inertia is J, which is in kilograms, and rotational frictional coefficient, which is B, Newton's meter, and stiffness of the spring, which is K. So these are all the ideal elements that we are going to use when solving the problems. So coming to mechanical modeling, so fundamental dynamic equation is T of T is equal to J into d square theta by dt square, since we have acceleration inertia. So acceleration is d square theta by dt square. So J plus B into d theta by dt, which is velocity, and K is theta, which is displacement. So J d square theta by dt square is the torque needed to accelerate the inertia, whereas B d theta by dt is torque lost due to damping. K theta is restoring the torque due to stiffness. So we all know that spring, however, when we drag it, again it moves to the same position. So it is restoring torque due to stiffness. And coming to the applications of mechanical rotational system. So in day-to-day life, we use bicycles and fans. So rotating fan blades were a fixed central axis when torque is applied to the motor. Whereas coming to the bicycle wheel motion, so wheel rotates about its axle, enabling forward translation of the bicycle through rolling motion without slipping. So this is mechanical rotational system. And let us summarize. Like in mechanical rotational system, we learnt about the basic elements, which is moment of inertia, friction coefficient, stiffness of the spring, applied torque, angular displacement, angular velocity, and angular acceleration. Coming to the modeling, it works in Newton's second law of motion, which is fundamental dynamic equation, and torque, which is J into d square theta by dt square, which is acceleration. And coming to B, damping, which is B d theta by dt, which is velocity. And coming to spring, which is k theta. And along with the applications like DC motors, generators, flywheels, rotating fan blades, bicycle wheel motion, all these are some of the examples. So let us here have an assessment. In a mechanical rotational system, the damping torque is proportional to angular velocity, because B is d theta by dt, which is angular velocity. And which of the following system is best to model as a mechanical rotational system in control analysis, which is DC motor shaft rotation. So let us meet in the next video. Thank you.